Hello, bio students. I'm going to show you how to complete the modeling protein synthesis activity on your handout, where you'll be modeling the major processes of transcription and translation. Starting on the left of your sheet, you have template DNA. And so DNA codes for proteins, and the way that this is going to function across the page is that 3 bases of DNA, referred to as a triplet, result in the coding for 1 amino acid. And so across the page, the end result is 1 amino acid that's going to be added to the polypeptide chain. Amino acids are the monomers or building blocks of the polypeptides that make up proteins. The first thing that you'll need to do in looking at your template DNA is determine the messenger RNA that is complementary to it. Messenger RNA is formed when an enzyme called RNA polymerase builds it by complementary base pairing with the DNA. That's what transcription is. The 3 bases that result of messenger RNA are called a codon. So for every DNA triplet, there is 1 messenger RNA codon. So complementary base pairing is going to be C's and G's together, and then adenine and uracil. Remembering that uracil is the base that is present in RNA, there is no thymine in RNA. The next thing that you're modeling is the movement of that messenger RNA from the nucleus to a ribosome. So you are rewriting those 3 letters that you determined as new messenger RNA here, over here in this column. Now the messenger RNA is at a ribosome. The 3 bases that made up your codon are going to have a complementary match in a tRNA anticodon. So the 3 bases of a tRNA molecule are referred to as an anticodon, and they are complementary to your messenger RNA codon. So C's and G's together and A's and U's together. Every tRNA has a specific amino acid that it brings in. To identify that amino acid, you're actually going to refer back to the messenger RNA codon. That is what's more typically presented in a table to look up the corresponding amino acid. And this is one format of a table that exists to do that. So the codon I want to look up is UGG. So I'm going to go to the table, and this is on the back of your paper, and go to the table that starts with U, since that's my first base. My second base is G, so I'm moving down here, and my third base is G. That codes for the amino acid tryptophan. So I've just written the 3-letter abbreviation TRY for tryptophan. I'm going to take a moment to point out on this table that here you see tryptophan and cysteine above it and below it. That means there's more than one way to get the amino acid cysteine. UGC would code for cysteine. UGU would also code for cysteine. So what this means is that more than one DNA template could end up resulting in the same amino acid. This is important down the line for whether or not changes in your DNA or in an organism's DNA matter. And some changes in DNA will still result in the same protein production because they'll code for the same amino acid. And so therefore those changes don't have an impact on the organism. All right, now try the next triplet. GTA is the next triplet of DNA. So noting here that what you're doing first is writing the complementary RNA bases, so you're modeling formation of the messenger RNA. That's transcription happening in the nucleus. Then you're going to move that messenger RNA over here. You're modeling the movement of the messenger RNA from the nucleus out to a ribosome. Then you're going to write the 3 complementary tRNA bases. So you're modeling the tRNA anticodon matching up to the messenger RNA codon. And then you're going to use the messenger RNA codon table to look up the corresponding amino acid. And as you move it one more time here to the right, you're modeling that growing polypeptide chain that is a chain of amino acids which can fold as part of a protein. Take a moment and finish that triplet across the page as needed and try to look up that amino acid. Here's the solution to that section. The amino acid is histidine. Now try the next one. You can pause the video if you need more time. Here's the answer. Now you can reinforce that process by continuing and completing the rest of your page.